before we go into hardware. Now here's just a recently completed project we've done, and usually when we design a building, we start with a low energy idea. So with this particular apartment block, our idea was to have a flue in the middle so that we could naturally ventilate on the inside, so that both the outside and the inside of the building would have cooling winds. And so in this way, we would have a cooler passageway inside the middle of the building, and as well when you walk from the elevator core to the apartments. And so what we've shown here in the square, in those red rectangles, are a series of air wells that are on the inside of the building, and then we started to simulate. Oh, sorry, this is the wrong diagram. But we started to simulate the use of wind in the parts of the building, and that here's the drawing that shows the air that goes through the inside of the building, and they started to simulate using CFD the effects of wind at the incidence to the facade, one facade to the other facade. And this diagram shows I hope you can see the colors, the comfort conditions on the inside of the building. That acceptable condition would be somewhere between the light blue and the really dark blue. And so at the simulation stage, it shows that the building works, and that in fact the building's been measured post-occupancy now, and the reports are here that it actually is working. And at the bottom of the tower, we have scoops that actually scoop the wind and drive it to the upper parts of the building. And we had to sunshade the building, and so these are the details of the sunshades, and these were studies to show the shadows that cast on the inside of the building. Let me just go back to an earlier diagram. This one that shows that with the sun shading, you can see the comfort condition is that little red graph, and without the sun shading, between 12 o'clock to 6 o'clock in the afternoon, you can see the comfort conditions shooting all the way up into in that blue graph.